Now, if you take the architecture, you will realize that there's a certain arrow over here which runs through all the way to the end here, okay, which runs through all the end here, right? So the key to this LSTM is the cell state, okay. We call this one the cell state. So you see that we have CT, okay. So this is the current cell state, okay, and then this is the previous cell state. So CT minus 1 is the previous one, CT is the current one, okay. We see that the horizontal line is running through the top of the diagram, as you can see, and this is more like a conveyor belt, okay, which runs straight down the entire chain, right, with only some minor linear interactions, okay, some minor linear interactions over there, just some minor ones over there, right? And it's very easy for information to just flow along it unchanged, okay. It just easily allows information to just flow along like that unchanged. All right, so that's the line that you see up here is actually connecting the previous cell state to the current cell state. All right, so let's see the next one over here. All right, now the next one over here is, you see that if you look closely, let me even use this one, right? If you look closely, you see that we have this part over there, right? So this is the part that I'm cutting out. Okay, I'm cutting out this part. You have some sigmoid over there, some arrow going up, and then some point-wise operation over there, remember, right? And then here the operation is, multiplication. All right, so that's the part that I'm cropping out to let you know. So, all right, so that's this part. All right, so let's try to understand. All right, now the LSTM does have the ability to remove, right, to remove or add information to the cell state, right? Remember, the cell state is the arrow that we saw, okay, where we have the previous CT minus 1, which is the previous cell state, and then CT, the current cell state. Okay, so it has the ability, the LSTM has the ability to remove or add to the cell state, okay. Now, carefully regulated by structures called gates, okay. Now, this is what we refer to as the gates, all right. Now, gates are a way to optionally let information through. They are composed of a sigmoid, which is this, okay. That is a sigmoid neural net layer, right? And that is what I showed you. And a pointwise multiplication operation, okay? Pointwise multiplication operation. So this pointwise multiplication operation together with the sigmoid neural net layer, right, together forms the gate, what we refer to as the gate. Now let's see the function of this one, right? Now this sigmoid layer output numbers that are between 0 and then 1, okay? Describing how much of each of the components should be let through. Right, now a value of 0 means that we should let nothing through, okay. So if this sigmoid here comes up with a value of 0, it means that whatever information that was coming here, we are not going to let it through, right? We're not going to let it go beyond that. We're not going to let it through. However, if we come up with a value, say 1, right, it means that we're going to let everything through, right? Which means that if sigmoid comes out with a value of 1, then whatever that is coming here is just going to be allowed to pass through and go to the current cell state, just like that. All right. Now, an LSTM has 3 of these kind of gates, right? The input, the output, and then the forget gate. Okay. Let me even go back here. Okay. Now, let me even show you all the other gates. Okay. So here we have this one, which is the forget gate. So the first one here is the forget gate. Okay, this one is the forget gate. Okay, and then we have this one to be the input gate. Okay, and then we have the output gate over here. Okay, this one is the output gate. Okay, so the forget gate is trying to decide what information we should forget, right? Because this one is information which is flowing from the previous LSTM, okay? So we need to decide which information we should retain, which one we should update, which one we should forget, okay? And then once we decide that one, then the input gate is going to take that input, right? And then together with this tan H, decide which information to allow over here. And then the output gate is going to give us the output finally, okay? It's going to decide which information to output. Okay, so this is the 3 that we have, right? The forget, input, and then the output gates. All right, so let's try to now understand the steps, okay? The steps that go through, right? That flows through right from the beginning to the end. in this LSTM architecture. Okay, let's see how the information flow through this LSTM architecture. All right, so as I said, the first step in our LSTM is to decide what information we are going to throw away from the cell state, right? And then the decision is made by the sigmoid layer called the forget gate. Okay, so that is the first one here. It's called the forget gate, and that's what made that decision, what information we are going to retain, right, and what information we are deciding to forget. Okay, now what it does is that it takes the previous hidden state, right, and then join it with the current data, right, and output a number which is between 0 and then 1 for each of the number in the cell state C, that is the previous cell state. Okay, so what it's doing is that it's taking the hidden state over here, which is the HT, combine it with XT, okay, combine it with ST, and then use some sigmoid function to decide which information to go out or not. Okay, and that is going to output a number between 0 and then 1. Okay, so if it's 0, nothing of these things are going to be allowed to go through. If it is 1, all of them is going to be allowed to go through. If it is any value between them, for instance, maybe 0.9 or 0.8, okay, if it is close to 1, it means that majority of the information coming from here are going to be allowed to go through. But if you have something like, say, 0.02, right, which is very less, it means that very, very few information here is going to be allowed to go through. Okay, so if you take example, maybe your previous state, hidden state, you have information like maybe he, right, maybe he, something like that. He is, let me clean this one up and do it. Okay, maybe he is eating, maybe just like that, maybe he is eating, something like that. And then now the information that you have is she is eating. Okay, now in that case, this one is going to decide that, okay, the information that is coming from my previous state, I only need to change the he, right, to she. Okay, so in that case, I'm going to forget only a few information, and majority of the sentences are going to be allowed to pass through. Okay, there's only a few of them that I need to update, just the he to she. That's it. Okay, but if for instance this one was she, maybe she is bathing. Okay, now in that case I need to forget he, I need to forget eating. Okay, and in that case only a few information would I allow to let go through. All right, so something like that. All right, so that is it. And then if you see the equation, it's just simple. We are combining HT, the previous hidden state, which is HT minus 1. Okay, the current hidden state will be HT. Okay, it will be HT over here, which will be a current hidden state. And then we combine it with the current data, which is what you have over here, HT minus 1, and then HT, and then ST. Okay, and then we multiply with some sort of a weight. Okay, remember there will be some, if you combine this thing, you need to multiply with their respective weight in the hidden state. Okay, plus some sort of a bias, and then you apply the sigmoid function on it. Okay, and then you put some values between 0 and then 1. Okay, and that's gonna give us our FT, which is here. All right, so that's the equation as well. Okay, now that's just the first step. Now once you're done with this first step, you move on to the second step, which is nothing but the input gate. Okay, which is nothing but the input gate. Okay, so the next step is to decide what new information we are going to store in the cell state. Okay, what new information we are going to store in the cell state. Okay, and this has two parts, right, which is the first part being the sigmoid layer called the input gate. Okay, this part called the input gate. Okay, and which decide values we will update. Okay, so this one is going to decide which values we are going to update. And then the next one is the tan H, okay, the tan H layer, which creates a vector of the new candidate values CT. Okay, new candidate values CT. All right, so we have the old state and the old information coming in. Sigmoid here is deciding how much we are going to, how much of the new information we are going to store, right, in the cell state. And then this one here is deciding the current sentence that we have. So for instance, the example that I gave earlier on, right, he is eating, right, he is eating, and then we also saw she is, say, bathing, or something like that. So now this one, this sigmoid here, deciding which of these new information we are going to store, okay, which of the new information we are going to store in the cell state, right? And then the TAN-H, right, the TAN-H layer is creating a vector, okay, of the new candidate values. It's creating a vector for these new candidate values. Remember this one, how much we are to retain here has been decided over here, right, in the forget gate. Okay, now for this particular stage, we are only dealing with the new information. Okay, how much of these ones we are going to store in the cell state. Remember, the cell state is nothing but the line that is passing through here, right, which is going to give us the current cell state, right, stemming from the previous cell state CT-1. Okay, so here we are only deciding how much of the information we are going to retain, how much of the new information. So here we need to retain the she, we need to retain the bathing. Okay, the is going to come from the previous state because is here, is here. So here we will maintain is, get rid of the eating and the he. Okay, this one will help us decide that. And then this one will help us decide which of this one. So we have to maintain, so that we not maintain redundant information. We are maintaining she and then bathing over here. Okay, then we add she and bathing to is to form the sentence in the next state, which is going to be the output that we're going to get. Okay, all right, so if you see the equation over here, right, so we have the first one that we talked about earlier on, right? We have the ht -1, that is the previous hidden state, with the st, that is this one with that, okay, which is coming in. Okay, and then we apply the sigmoid on them, right, a sigmoid on them, and then we're going to have the it, right, here is it, so we're going to have the it as a result. Okay, and then here we're going to have the same ht, and then ht -1 and ht, right? Remember, this one is also flowing through all the way here. Okay, so this TAN-H, right, is going to work on that, right, multiply by some weight and some bias, okay, over there, and then we're going to have the ct respectively. All right, so that's basically what is going to happen in the input gate layer. Okay, all right. Now, once that part is done, then we come to this second part. Now, it's now time to update the old cell state, okay, to update the old cell state, because we have the old cell state, which is CT-1. We need to update it so that we will get the new cell state, which is CT. Okay, now the previous steps already decided what to do. We just need to actually do it. Okay, previously we have decided which information, the old information to retain, which new information that we are going to also put in the cell state. Okay, we have also decided over here. All right, so we just need to update it. That's the only thing. Okay, so here we multiply the old ft, which is the result that we got. All right, forgetting the things that we decided to forget. Okay, which using the pointwise multiplication. Okay, and then we're going to add. Okay, we're going to add the it and then the ct. That is the it result that we got here, and then the ct result that we got over here. Okay, and this is the new candidate values that we're gonna get, right, scaled by how much we decided to update each state value. Okay, so it's just like this: ft, which we got over here, multiplied by CT-1, which is the previous cell state. Okay, so ft multiplied by this one. So here we're gonna have this ft, right? Ft multiply, okay, this multiplication pointwise operation over here, multiplied by, okay, multiplied by the CT-1, okay, like that. That's what you have over here. And then for this part is going to be this one multiplied by this. Remember, we have a pointwise multiplication over here. Okay, then in addition we add both of the side. Okay, we add both of the side, which is this one we have found, and then this one here. So that's what you see over here. That's what's going to finally form this one. It's going to give us our CT. Okay, that's what it's going to give us, our CT. All right, so once we are done with that one, then we go to the final stage, okay, which is going to the output stage, or the output gate. Okay, so now here we need to just decide what we are going to output. Okay, we need to decide what we are going to output here, and this output will be based on our cell state. Okay, it's going to be based on our cell state, right? But it will be a filtered version. Okay, it will be a filtered version. It's not that the information is just gonna pass through like that, right? We need to do some more thing over here, right? First, we're going to run a sigmoid layer, which decides what part of the cell state we are going to output. Okay, so we have decided to get our cell state. Okay, but what part of that cell state are we going to output. Okay, what part of that cell state are we going to output? So the information which is coming from that previous one that we have decided is going to pass through the sigmoid. Okay, and then we're going to multiply it with the CT that we have. Okay, but before we multiply, we need to apply some sigmoid on that CT. Okay, before we do that pointwise multiplication. Okay, so here you can see that we have our HT, and that is the previous hidden state multiplied by the current data. Okay, that's flowing through like that. Multiply by some sort of a weight. Okay, there should be some sort of a weight and then some sort of a bias. Okay, then we apply the sigmoid on it. Then we're going to have this OT. Okay, you're going to have this OT. Then after that, we're also going to have the OT, right? That result OT multiplied by the CT, which is coming, which we have applied the tan H on it. Okay, tan H on the CT. Right, we multiply both of them, right, and then we're going to have our final output, which is HT. Okay, so this one becomes now our current hidden state. Okay, which we can now also base on to build the next one. Okay, based on, so this HT is also going to be HT minus 1 to another. Okay, just like this one was also coming from another one. Okay, so this output here is also going to be fed into another LSTM, right? And then the process will keep on continuing, right, like that. Okay, so that's basically the entire doings of this, right? So as I said, this is just one of them that we have seen so far, right? So this one was having information from the past, right? And now once we get this one, then this information is also going to flow to the future one, right? The one that will come after that, and it's just going to continue like that. Okay, it's just going to continue like that. All right, so this is how LSTM actually works. Okay, this is the entire architecture of LSTM and how information flows through and how it works. All right, so I hope you get understanding of this. I urge you to watch it one more time. As I said, to reinforce the concept is very, very much important. Don't just watch it once and relax. Watch it one more time. Okay, watch it one more time. This time, be intentional of every detail of everything that I've said. Okay, be intentional of it. Watch it one more time. All right, so take your time to watch it again, right? And don't forget to give a good rating and a good review to the course. If you have any comment, or if you have any confusion, anything that you want to ask, just put it at the Q&A session. Okay, I'll be there to respond to it. All right, so that's it for LSTM. We're going to see implementation of this in the lab session. All right, so see you in the next tutorial. Have a nice day.